Good morning, everybody. As with the previous sessions in this General Assembly, we decided to lead the session by example. So you heard two presentations about how seasonal forecasts are being used in the operational part of the service already. What I want to do now is to take very little of your time in just hitting some highlights and bringing up some key points to improve your understanding of the context in which these activities operate. I haven't listed the authors and the contributors because there are too many to mention, but hopefully I will manage to acknowledge their contribution as we go through the very stark list of no TED talk here, by the way. So let me start with something that's possibly the most visible and certainly one of the things that's been most commented about, the contribution that C3S has made to the IPCC in its sixth assessment report through its support of the Climate Atlas. I will not go into details because we have a talk about this next, as well as about what might involve evolution of this part of the service. But it is fair to say that it is one of the things that has captured the attention of our management and potentially users as well. More mundane, though much, by a lot not less important, is the second point about climate projections that I wanted to draw out. It is the transition of the infrastructure that we use for the service on climate projections from a 3 SGF node infrastructure to 2 nodes. You might think, what's the big deal about that? Well, the first big deal is that probably none of you noticed that that happened. Which is actually as we wanted it. The unfortunate thing is, though, that was forced upon us by our inability to continue working with UK contractors. So one of the most actively participating contributors, the SGF node in the UK, could not continue to work for us. So a lot of work had to be put in place, especially by IPSL, to redesign the bid and the contract and to manage to transition the service from the old infrastructure to the new infrastructure without affecting users in any way. In fact, we'll probably have to extend and to modify again the concept behind the infrastructure because more data sets will be coming online, which may involve something more sophisticated than just copying data in a number of nodes. That is, by the way, no longer much of a realistic possibility anyway with the volumes of data that the CIMIP and other climate projection activities are producing. I will swiftly move to predictions. And maybe just to ease you into the timescales, I will just highlight the activities that happen in the decadal prediction prototype that we developed in the last couple of years of the Copernicus 1 phase. Just to say that we recorded successes and we learned some really valuable lessons. And personally, I'm as much inspired by the lessons we learned about what doesn't work as I am by the successes that we hit. We will be trying to put the useful elements that we found there into use. I'm not going to say much more about this because the next talk is going to explain much more about what that involves. For seasonal predictions, Eduardo did a job I couldn't possibly better in telling you what's available now, but I do want to highlight a couple of things. Firstly, the contracted contributions, which have allowed us to continue this multi-system prediction service, which has a lot of users. I wouldn't say it's the most valuable or is very valuable, but it does have a lot of users and very, very inquisitive users. So this is why user requirements are multiple for this part of the service. In addition to the contracts, we do have in-kind contributions. And we are always grateful for these contributions, but they always create us complexity in trying to implement things. At the beginning, that was a big overhead. It's becoming less and less of a problem to do this, not because it's becoming simpler, but because we are becoming better at it. It is an exercise that involves not just people in a seasonal forecast team at C3S, but also people in a forecast department, people in a computing department, too many to mention, many of which are in the room now. Now, maybe I'll alter the order a bit, because this reminds me immediately about the point on the continuation of the operational service and the necessary migration of the code that deliver all this to a new supercomputer. I spotted that Sean mentioned this before. Again, for those who've not had to deal with the migration, you might think it's a bit of a boring technical bit, but it has been all-consuming for many of us, and it continues to be. In fact, our aspiration for the rest of this year is to make sure the forecast goes out without a glitch when the transition actually happens. New products have been created. Again, Eduardo has shown us a few. We've created data packages and outputs and applications to serve some users. We haven't gone as far as we would have wanted. There's still a lot to do. It involves, again, a lot of infrastructural work. But we have added to the graphics. So we have created some indices describing climate variability modes that people were asking for. In effect, everything we've implemented was in response to people's declared needs and intentions. So graphics indicating stratospheric winds in winter are very valuable. You find people quoting our graphics on our social media often. The same for the Indian Ocean Dipole. Lastly, the C3S evolution requirements have reached us. We've contributed to specifying the requirements which would need to be addressed. The European Commission formulated a call for research projects for this. And C3S is going to be very closely involved in these projects to ensure the relevance and the smooth path towards implementation of the outputs of these projects. One more slide about what happens next. I'll try a bit of suspense here. So the IPCC Atlas is going to make its way in a climate data store, and it will be evolved into a C3S interactive climate atlas. Jose Manuel Gutierrez will explain in a minute how that will be done. We are going to introduce new climate projection data in a CDS. And we want to improve the functionality, the web processing services, which allow users to pre-process the data before downloading. This should help not only people who have bandwidth issues and data storage limitations, but also people who genuinely want to just make use of the last step. There are limitations, both technical and in terms of resources, but within those limitations, we are hoping to add data. Again, the user requirements will be key because we need to prioritize. In terms of predictions, we want to continue to make efficient and substantial progress towards answering user requirements, expand the applications and the sort of self-help information available, create more products, and archive and be able to deliver highly processed products. We expect additional in-kind contributions to the multi-system. Now, some of you might wonder, haven't we got enough? We have 8 contributions already. It's a fair question, but I personally believe that we haven't yet completed our journey through finding out how to extract information from these forecasts. We know that, on average, multi-model combinations are better than individual models. We don't quite know whether selecting highly tuned combinations is a good thing or a bad thing. I think we still need to do this, and to be able to answer the question, we need to put all the data that's being offered to us in the hands of users to try and determine this. One mention here may be the contributions from the UK Met Office, which some of you have used in the past, will have to become in-kind contribution because we cannot continue to fund them as contractors. So at the moment, if you ever plan to rely on those, I would urge caution. In terms of longer-range predictions, we plan to introduce in the CDS data from the decadal predictions, from the prototype service we developed last year, and from the decadal climate prediction prototype more widely, and possibly to engage in creating multi-year predictions from the current C3S seasonal systems. Lastly, we want to do more work on user or decision-relevant products from multi-year predictions like the decadal predictions that the prototype has initiated. I will stop here, and if you have questions at the end, once you learn about what the prototype has achieved, I will answer them then. Thank you.
That was impeccable timing and a very clear overview, Anca. Thank you very much. Is there a quick question? Yes, we have one here.
Maybe it's a stupid question. Why you can have the Japanese data and not the British one?
We don't pay the Japanese. We have paid the British up until now. So the in-kind contributions are literally in-kind contributions. They send us the data. They go to some length to make an effort to adapt to our standards as much as possible. They never achieve them perfectly, so we need to adapt our processing to take into account. The UK have adapted to the standards because they've been under contract up until now, but the requirements of the service involve and require them to boost the operational system, to create more ensemble members, to maybe update more often. And frankly, this source of funding that they had for the last 4 or 5 years has dried up suddenly on them. And they continue to send us the data now as in-kind contributions. But if we ever need to go back and say, give us more variables, do something more, we have lost all authority to push for that. As Alberto asked earlier, we do receive requests from users. And one of the judgments is, can people output this data? Because many times the data that the users are asking for is not output, so we need to wait until the next update of the operational system. So we hope to be able to persuade them to participate in kind, but it's all a function of their kindness and their ability to do so. I believe the UK are under strain at the moment in terms of resources.
Thank you very much, Anca.